Hey guys, guess where I am? At the Sunken Garden. Anyway, um, so today we're going to look at formulas, names, and dates in Excel, of course. So to start with formulas, we looked briefly in last video that how to structure formulas. It starts with an equal sign, and then you can put some formulas and chuck in some inputs. Then it's going to voila calculate some values. But to better use those formulas, we need to understand some operators first. Of course, some of those operators may be very logical, but you might find some of them you haven't seen before. And do note that in Excel and Python, although some of them will overlap, not all of them will have the same meaning. So for instance, we have here exponentiation with the hat, but in Python we use two star signs, right? So we'll have a look at the Python stuff later on. So operators in Excel, addition, subtraction, multiplication, and division, as you would expect them to be, the plus sign, the minus sign, and so forth. Exponentiation is the hat that we use, and text concatenation is the ampersand sign. So if you put ampersand sign, that just means that you're going to add a text as an input next onwards. This becomes quite useful every now and then, but you'll probably find it out through different examples. We also have logical comparisons. So here we have the single equal sign. Later, if you go to Python, it's two equal signs. Again, we'll cover it later. Not equal sign is the sharp brackets facing both directions. Less than, greater than, and those should be quite straightforward. All right. So let's look more into functions. Right. So we looked at last time how the functions are structured. So after the equal sign, you call the function name, right? And you open the bracket to pass in the parameter, right? So you can have multiple parameters as necessary, and each function will tell you exactly how many parameters are expecting and what kind of types of parameter you need to input. Okay. So here's an average function as an example. Calculate an average of values between C1 and C15. Okay. Sometimes it's kind of difficult to know what kind of functions are out there. You might know some features, but that feature may not necessarily map to the name you have been thinking of. Then you can always search for those functions in Excel. So in Excel, let's reduce this a little bit. You go to formulas, and you can press insert function, and here you can type some stuff. So maybe I want, I don't know, standard deviation. It's going to show me a bunch of standard deviation related functions. I can read the description and then use the one that is most appropriate. So calculate the mean, mean, then it's going to give me some descriptions that include the term mean inside, although it may not exactly find the suitable one. You'll eventually get there. For example, I found the average one here. Okay. Alternatively, you can press the function sign. So let's try that. So here, there's the fx. So whichever ribbon you're in, I can press this, and it's going to show me exactly the same options here. Okay. Of course, you can restrict yourself to the specific category by selecting one. Okay. So this will make it easy for you to find the appropriate function that you need to use. So let's have a look at an example if. If is probably one of the most used function in Excel and in other languages as well. So it's very commonly used. It's a logic within a worksheet that determines what to do. So if it's true, you might want to do something. If it's false, you might want to do something else. So let's have a look at an example. So if function, if you look inside, it has 3 arguments. Argument 1 determines the condition that you want to check. Argument 2 is if the condition you give in argument 1 is true, then you do something with it. If the argument 1 is false, then you move on to argument 3. So let's write that out. So here equals if, I'm not going to put it into Q, maybe F1 is greater than equal to 0, then I'm going to calculate minus B1 plus square root. So here I'm calling another function square root inside an if function. So you can nest the functions if necessary. Square root, we said F1, close the brackets, divided by 2 multiplied by A1. Might not use A1, nevertheless it's fine. Okay, so that's true. Now you can see it in my Excel sheet. As soon as I press comma, it tells me, it bolds the text value if false. So it tells me that I'm moved on to the last argument. So if it's false, I just say it's imaginary, because Excel doesn't really handle imaginary values. So in here, I do have to put some number in it. If it's 1, it's going to calculate some hideous number because my references are in F1. Oh, F1. Okay, way up there. I should have put it there. So if it's 1, I can calculate some value, but if I make it into negative value, then it's going to show me the argument that I put inside in the false condition. Okay? So that's how if works. So function arguments can be various things, not just numbers, but a cell reference, values, or even names. And full rows and columns omit the number or the letter. For instance, if I want to select every number in the C column, then I can type equals average C to C. And as you can see here quickly, that it's going to highlight all the values inside C. Okay, and press enter, that's going to calculate me values. So anywhere in the column C, I can add some values. It will automatically update my formula accordingly. Okay, so let's get rid of those two and the if as well. And you can do the same with the row as well. So if I want all the rows, the sum of the rows in 6, then I can go equals sum 6 to 6. And it's going to highlight me again the row 6 all the way to the end, how many columns that I have. And it's going to calculate me the sum. Okay. Literals just means specific values that we can put in. Expressions, so I can add other mathematical equations inside a function. So for example, the square root a1 squared plus b1 squared. Okay, so this calculates me 93.59 and whatnot. Okay, and this will be probably right if I used a1 and b1. The results of another function, so I can nest the functions as I shown you before. So this one equals log of square root of a1 and give a base of 3. Okay, it calculates me 1.9 as a result. So these are all sorts of different types you can combine them to. Okay, and it works with different types of functions as long as you match the function argument requirement. So if it's expecting number, you need to give it a number. If it's expecting some string, then you need to give it a string, and so forth. Okay. Categories of functions. So broad categories of functions are financial, date and time, mathematical, trigonometry, statistical, and it goes on, right? So there's a lot of functions that does a lot of different things. Again, It's all about learning different types of functions and using them in an efficient manner. So the full list can be found, I have a typo there, from insert function, and you can see them there. So insert. No, formulas, insert function, sorry. And then here I can select all. It will show me all the functions that I can use in my spreadsheet. So again, so now we're going to look at some examples of formula. So again, ampersand value is the concatenation of strings. So here I can say if I have some string values, John Doe in ENF3, and then I can say equals name is, so this is a string. To represent a string, you put it inside a double quotation mark, and then I'm going to use the ampersand, reference the cell that contains the string that I want to concatenate, like so, and then hit enter, and then it says name is John Doe, and you can probably notice that there is no space between John and Doe as well as name is. That means you have to input the spaces manually yourself if you want to format this nicely, because the program doesn't know exactly where the spaces need to go. Okay. As we've seen before, we can do the square root by using the hat. Not the square root, we can do the power function using the hat. We can do the conditions, and if you put comparisons in an equation, it will evaluate as a Boolean. Boolean results are either true or false. So let's try. So this one equals A1 is greater than B1. Okay. In this case, it tells me false because A1 65.1 is not greater than 67.2. So this one tells me it's false. But if, say, we change the sign to the other way, then it's true because 67 is greater than 65. Okay. And you can combine this in all sorts of ways. So we can hear or, which means A1 is less than 2, A1 is less than A2, or A1 equals 1000. If either condition is true, then it's going to give me true, otherwise false, right? Whenever we have lots of conditions that we are combining to reduce confusion or avoid confusion, please add brackets to make sure that you separate out how the logics are laid out in your formula. Now moving on to the named cells. So as we've seen before, we normally select like a ranges. So here the average, if you can see it, average equals A1 to A10, but this is referring to science and engineering, although I wouldn't really tell by looking at the formula. So what we're going to do is name the cells. So you can either name single cell or group of cells together. So if I select A1 to A10, here you can give it a name. So I'm going to say Sci-Eng. Okay, and once I press enter, if I select the cell range, it's going to say it's Sci-Eng. Whenever I press single one, it's just going to refer me back to the cell reference. Whenever I select the range, it knows that this name is Sci-Eng. So instead of using average A1 to A10, now I can use the name equals average Sci-Eng, and it tells me that there are potential name matching Sci-Eng. So if I press enter, it's gonna give me exactly the same answer. And again, because my width of the cell is wide, it is longer to capture. Okay, so instead of seeing average A1 to A10, by reading average science engineering, it makes more sense as a reader to just reference that cell. So I can do the same with this column. I can give it a name called Sci, and I can give the next one the name BCM. Okay, then I can use those names instead of the ranges. Here, average Sci, and equals average BCM. Okay? So now those all give me exactly the same answer, but by looking at the formulas, I can better understand what values it's referring to. And again, you can manage those names. I think I have it in the slides. We'll come back to that. Whoa. Something's moving in there. Did you hear that? I hope it doesn't come. Anyway, so name can be managed here. So all the names that I assigned goes into the name manager. So there are some rules applying to names. For example, it must start with a letter. You cannot start with a number. And also it has to be long enough so it doesn't reference another cell. So for example, I want to name this range called XFD104876. Unfortunately, that is actually at the end of the Excel spreadsheet. So I can actually go that far or further down too. So if I'm referencing another cell, you cannot use that as the name. Okay, so let's go back up and to the top. I just have to go type A1, it will take me back there. Okay, and also you cannot have names with space. Instead, you can use underscores, backslash, and full stops. No other special characters you can use in there. Names can be up to 255 characters, and remember, names are not case sensitive, which means even if you put case sensitive letters inside names, Excel doesn't really care. So I went through some examples just before, so I'm just going to move on. So defining a name is pretty easy. So just like I did before, you can select the cell or groups of cells together and then give it a name in the top cell here. Or you can use the name manager. You can add new ones, edit the existing ones, or even delete them. So here, go to the name manager. If you want to remove a name, go to formulas, name manager, and select ones and delete. Okay, so the last thing we're going to look at in this video is dates. Dates are simply numbers in Excel, but with data formatting applied to them to indicate that they are dates. Do note that the very beginning of the date for Windows starts from 1899, December the 31st, or if you're on a Mac OS, it starts from 1904, January the 1st. So if I want to use the date represented as date in Excel, the time before that, it doesn't recognize. So let's try that. So go from here. So if I say, so 1st of January 2020, it's going to recognize that as a date and put it into a nice format for me. But if I want to say 1st of January 1899, it doesn't really know what to do. So here, if I expand the column a little bit, you can see that the date that I put in as a 2020 is nicely aligned to the right, but this one is not because it wasn't recognized as a date. But if as soon as I change this, so 1900, boom, it's recognized as date now, so it does the formatting by itself. So be wary that you cannot use the date that is older than 1899 on Windows or 1904 on Mac OS. Okay, so here's an example. You can even do date calculations because dates are just the number of days starting from these starting dates, right? So say if I want to convert this back to the number type, so go here, instead of date, I press number. It's recognized as 1. So if I want 1 year later than 1899, then I put 365, and then convert this into date, short date. Okay, then I go to the 30th of December 1900. Yeah, so Excel, all it's doing is just interpreting a number and matching it back to the minimum dates that they start with. Okay, so I can format those type as dates, and I can calculate it as well. So let's try exactly the same thing. This one is 13/3/2003. The next cell is 28/8/1958. And on the next cell, I just go this cell minus this cell. And it's going to give me a number because all those dates just represent a value inside Excel. Okay, so if I can convert this back to a date type. So if I change this to date, it will show me some date format, although it doesn't really mean much. It's just going to represent whatever the value inside here, and then take that many days after its beginning date. Okay. So that's it for this lecture video. I'll see you in the next one. Maybe I'll be in a different place.